Hey, welcome to Del Q's YouTube channel. Are you a lonely Windows user? Do you find yourselves isolated and abandoned amongst the GNU Linux manly testosterone plus hacker men? Look no more. Today we are going to learn how to pass your USB Wi-Fi adapter to WSL and make it work in it. Hope on son, because your dual booting, VMwaring, arch racing days are over. Return to your true home for Windows is where you always belong. This endeavor was made possible through the godly work of EDMM악, so in his heavenly name do we pray. All the links, tools, and write-ups are available in the video description. So without further ado, let's get started. First of all, what is WSL2? Windows Subsystem for Linux is a virtualization technology made by Microsoft that allows you to run the full Linux operating system on Windows. However, unlike a virtualization method like VirtualBox VMs, there is no hardware emulation or software translation to do. Therefore, you get near bare metal performance of Linux on your Windows operating system. So cool, right? But Microsoft, being Microsoft, has developed WSL in such a way that much of the hardware components of your device are inaccessible directly by WSL, such as the USB adapters, whose control is required to put those devices in monitor mode, injection mode, etc., so that they can be used to penetrate Wi-Fi networks. This limitation is bound to the WSL2 kernel, while Windows itself does not have either the tools nor the drivers that allow these devices to be in monitor mode. Your favorite tools like Wi-Fi, Aircrack, NG, etc. and all the good stuff is only available to your Linux friends, and for Windows you have Wireshark and ComView. That's bullshit, and let's change that. Here our dear friend EDMMак has given us a patch WSL2 kernel with the instructions to add your own Wi-Fi adapters driver while compiling the kernel so that it can be loaded as a kernel module with your custom kernel image. So let's build our custom kernel and add our drivers for passing our USB adapter to WSL. Compiling the kernel is a resource-intensive process. You need plenty of RAM and CPU. You need a minimum of 10 GB RAM and no swap for it to run without errors. If you are planning to do all of this on your WSL, then make sure to edit the .wsl config at home/.wsl config and give lots of memory. But a better solution is to do this on a cloud VM like Azure, which is what I am on. Whichever cloud VM you are on, make sure that the Linux image you are installing is for the x64 for architecture and also is Debian-based so that it is more easy to follow, just like this tutorial. Make sure to give it lots of RAM. Here I have used the Azure E3 instance with 4 CPU cores and 16 GB of RAM. Next thing is to talk about your Wi-Fi card. In this tutorial, I am using a TP-Link AC600 Plus adapter, which has a Realtek 8810 chip. The first thing to do for your Wi-Fi adapter is to figure out what its chip is, and then search for its Linux drivers online. Most often you will find it on GitHub with the chip's name, such as RTL8821AE like mine here. All of these drivers are installed using DKMS, which stands for Dynamic Kernel Module Support. The driver files are compiled along with the kernel to produce object files, which can then be dynamically loaded and unloaded at runtime. So when we compile the kernel, we will effectively have a custom kernel image and the associated kernel modules, which are our drivers, which can then be loaded using modprobe. So I have SSHD into my Linux Cloud VM, and the first thing to do is clone the custom WSL2 kernel. I wouldn't recommend git clone as there's a shit ton of files. Instead, download the tarball and use tar-xvf to unpack it in your VM. Now you need to add and edit some files. CD into the archive and go to drivers, net, wireless, real tech. Here you can see directories with some drivers. You need to add your driver folder here. So as I have said earlier, this is my RTL881AU driver repo. A driver that is to be installed using DKMS has a certain file structure. One important thing to look out for is the dkms.conf file, which can be seen here. The core and other directories must have the C source and header files, which are going to become your binaries. So I am going to clone my driver's repo in here. Once you have done that, you need to edit the kconfig file and the make file. First, let's open the kconfig file. Make sure that the driver names you see here actually exist as directories in that folder. This driver actually does not exist, so therefore let's remove it. Then let's add our driver. Then open the make file and do the same. Remove drivers that you don't have and add your new driver. Make sure there are no syntax errors, because that will lead to fails during compilation and you might be starstruck. So double check them. Once you have done that, let's go into menu config to configure the packages we want in our custom kernel. To enter menu config, use the following make command. Remember, the config file for menu config is stored at Microsoft's /WSL config, which is where you are going to have your entire kernel build config. So when running make commands, be sure to run it from the WSL's topmost directory. Go to Device Drivers, Network Device Support, Wireless LAN, and then Real Tech Devices. Use the arrow down key to navigate. Here select the your driver that you just added by pressing M. Make sure that M is visible here or it won't be built. Then save the config and exit.
Try to stay.
You can see that the config is saved in Microsoft config WSL. Now we are ready to build. There are 3 build steps. First, the modules.
I can be with any longer. Split apart.
Before building, make sure that you have the following dependencies listed here. Install it using your package manager.
Tell me how I can fix your heart. Can't keep feeding on light any longer. I've tried. I've been all of these signs for the love that won't last. I don't wanna fall
Enter the make command to build the modules.
down. There's a way around it, so let me fix your heart.
If all your previous steps were done right, you should see all the source files getting compiled into .o and .a files, which are the compiled binaries. You should also see your drivers being compiled somewhere along the line. If you don't, you have messed up the editing of config file or make file, or the menu config entry. This is going to take the longest. This is where if you have memory bottlenecks, the build is going to fail, especially during loading the BTF and building the VM Linux binaries. So make sure you have sufficient RAM and disk storage. So sit back, relax, and be ready to say goodbyes to your Linux waifu, cause your new Windows waifu is on the way.
That soon everything will break to pieces. Wish it didn't go this way. Our love works so that I can stay and calling. So tell me how can I fix your heart? Can't keep feeding on lie any longer. I've tried, I've ignored all the signs for the love of one eye. I don't wanna fall down, push myself to the ground. There's no way around it, so let me fix your heart.
Woohoo, that took a while. Once that has finished, we are going to install the build modules. But remember, we are on a cloud VM server. We don't want to install our modules in here. So we add to this make modules install command this variable install underscore mod underscore path equals tilde slash WSL to dash modules. Run this command as sudo, and you will see that the directory has been populated with all the new modules including your drivers. Check in your driver folder and see if the .o file is present. See? The RTL82210.0 file is present, so you are good to go. Let's make a compressed tarball so that it's easy for us to transfer. Next, we need to build the kernel and get the kernel image. Run the following make command. Once it's finished, you can see the kernel which is named BGimage in this directory. Let's copy it to our user directory. Yay, you have all the files you need. Let's use the tar command to compress both the BGimage and WSL to modules folder into a single tarball named final tar.gz. You are almost there. Hang on. Now come back to your local machine and use SCP to download your final tarball. Now extract it using WinRAR. Let's quickly fire up a WSL distro and check the kernel before we start modifying it. Keep in mind the kernel version. Now shut down WSL, place the extracted BZ image somewhere convenient. I am going to place it in the Windows users directory. Now open .wsl config located in the Windows user directory and point to the kernel image as follows. That's it. Now pray for dear God and start WSL. If all went well, WSL should start as usual. Now run Unamar, and you can see that we are on our custom plus kernel. Hooray! You did it! Now we will copy the WSL to modules to the lib folder of our WSL root. Make sure the directory structure is preserved.
Floating through the sky, feeling so alive. Above the clouds where dreams collide, drifting on the wind, like a bird in flight. Leaving all my worries behind, taking flight.
CP commands can be confusing, so do follow the CD commands and copy appropriately.
For the light, dancing with the moon.
Go to your driver's KO file in the root lib folder location.
Fear, embracing the unknown, flying high in the sky, where I truly belong.
Now you have to load the 8821 UKO file using Mode Probe. For that, use the following command. Make sure to run it in sudo. If you saw no error, run lsmod to list modules and their status. You can see that our driver is loaded. Yeah, again, now all we need to do is to transfer our USB device from Windows to WSL. For that, we will use a tool called as USBIPD. We will download and install it. First, list the USB devices using USBIPD. Plug in your USB adapter and run USBIPD list again. You can see my TP link AC600 here and it's already shared, but for you it will be in the unshared state. We need to share it first. For that, we will use the USBIPD bind command. Make sure to pass the bus ID of your adapter as it's listed here. Then we will attach our adapter to WSL using USBIPD attach. Make sure WSL is running when you attach it. Then run iconfig. Voila! There you have it. Use the USBIPD tool to attach and detach your adapter. There you have it. The full power of Linux on your sexy Windows machine. Enjoy and make your Linux friends see. Bye!